Hello everyone, myself Dr. T. Rajani, Faculty of Physics from VNR JYOTHI Institute of Engineering and Technology. Today I am going to deliver a talk on synthesis of nanoparticles. So coming to the synthesis of nanoparticles, there are different techniques are used to tailor the properties of nanomaterials to decrease the size of any kind of particle from bulk level to the nanoscale. It can be scaled down in the form of films, in the form of powders, even for the liquid also we can do. So here different sizes of the particles will exhibit different kinds of properties also. This also it is one of the reason we have to choose the method very wisely. So having equal sizes exhibit different magnetic, thermal, spectroscopic properties depending on the kind of the preparation. So method plays a crucial role in getting the nanoparticles or in the nano size. So the various methods can be classified for the preparation in three different ways. One is the physical methods, and second one is the chemical methods. Third one is the biological methods. Coming to the physical methods, I have given here some of the major methods which we are using under physical, chemical and biological. All these methods have their own advantages and disadvantages depending on the availability, depending on the time, depending on the energy, temperature. We can adopt any of the method, and we can also adopt the method based on the size of the nanomaterial which we require. For example, if we are going for a targeted drug delivery, we require the nanoparticles which are in the size of 1 to 10 nanometers. If we are using the magnetic sensors or any kind of photoelectric applications, then we can go from 15 nanometers to some nearly 50 nanometers also. We can use this kind of material. If we are preparing NPN transistors or devices or any kind of system, any particle which is in the range of from 40 nanometers to 70 nanometers will also work wonderfully. So depending on the size of the nanoparticles and the availability, we can adopt any of these methods. Majorly under physical methods, we have mechanical methods, vapor deposition, sputtering deposition, electric arc deposition, ion beam deposition, molecular beam epitaxy. Under chemical methods, we have co-precipitation method, microemulsion method, sonochemical synthesis, hydrothermal synthesis, sol-gel method, microwave synthesis. Under biological methods, we can do these biological methods at our normal room temperature also by using the plant extracts, and we can use them by using the enzymes, by using different kinds of enzymes, different types of virus or bacteria we can synthesize, and we can also synthesize the nanoparticles from the agricultural waste. So there are some challenges for any kind of the method which we are adopting. If we are going for a physical method, it is a kind of energy and time consuming. A very high temperature we have to work, and pressure. Even in some of the for some of the nanoparticles, we have to use a clean air room, vacuum room to synthesize the particles. And coming to the chemical methods, it is very simple and inexpensive. The non-toxic materials we can choose to work in a normal four walls room, in a normal chemical lab, in a normal physical lab. And we can get the nanoparticles at a very low temperature. By adopting the low temperature also we can get. And we can do the large scale production. Nearly 10 grams or 8 grams to minimum to 10 grams of product can be prepared. But the challenge part is we have to consider the parent materials in such a way the toxicity gases will not be coming out. And chemical purification is also required at this level. Coming to the biological methods, it is very hard to control the size and shape, but we can control the size and shape in the case of physical methods and chemical methods, whereas it is not possible for the biological method. We can get the particles in the range of 1 to 100 nanometers, specifically a kind of a size, it is very little difficult to attain to that size and shape, and also stability. Stability also matters. Whereas the stability is maintained in the case of chemical methods and physical methods. And it takes a lot of time consuming for purification. Whereas in the chemical methods and physical methods, since we are working at a high temperature regions and we are working at a high pressure regions, and depending on the parent material, we provide a certain kind of temperature. There is time consuming is not a factor in the case of physical and chemical methods. But whereas in biological methods, for purification, it takes a lot of time. Crystal growth is there, but still organic materials, organic nanomaterials can be very well prepared by using these biological methods, like taking the extracts of the oranges, taking the extracts of pineapple. So from the fruits or vegetable extracts we can do, and from plants waste, dry waste extracts also we can prepare the ink or the conductive parts, conductive materials from these biological methods. So what are the key parameters for a person who wants to prepare a nanomaterial? What are the key parameters that need to be followed? Basically, when we don't have a sophisticated equipment or we don't have a kind of large equipment, we can establish our own lab, and the main ideas are the time, temperature and pH are the main key factors which we need to maintain when we are preparing. pH of the, because pH, power of hydrogen influences the texture of the nanoparticles. It works on the surface of the nanoparticles. And coming to the temperature of the reaction medium determines the nature of the nanoparticle you are getting. Whether you are getting a spherical shaped nanoparticles, whether you are getting a flower like nanoparticles, whether you are getting a long tube nanoparticles, a short tube length nanoparticles, it all determined by the temperature. And toxic elements are also getting exhausted when we are changing the temperature of the parent materials during the process of synthesis. Now the quality and type of the nanoparticle which was forming depends on the time duration we are preparing, or depending on the time duration in which the reaction undergoes. So apart from time, temperature and pH, there are other factors are also there when we are going for a physical methods, like frequency, pressure, concentration of raw materials used, method of synthesis, particle size and environment. So generally, how to fabricate or synthesize nanostructures? Generally, they are divided into two categories. One is the top-down approach. What do you mean by top-down approach? Top-down approach means building something by starting from with a larger component and carving away material. Like you are having a brick and you are scaling down to the size of the nanoparticle. Until that you are started grinding it. So then we say that it is a top-down approach. So like you are having a rock in your hand and you are changing the rock shape into a kind of a sculpture. So the best example for this is a ball milling method. This comes under top-down approach. And you can see here the diagram here. Here we have a kind of bulk material, and we started grinding it until it scales down to the nanoscale. Now coming to the second method. Second method is a bottom-up approach. So bottom-up approach is like building something by assembling smaller components. Like a atom by atom assembly until we get the structure. So the best example is the brick to building. So each and every brick we are using to form a kind of a structure, to form a kind of a building structure. So the method, one example is here, sol gel method is one of the best used environmental friendly method which comes under the chemical methods, which is a sol gel method. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.